after having understood this array notation, the next question that comes into our mind is, how do we compose two different permutations, or how does the group operation function composition is defined onto such permutations? So let's see how we may compose two different compositions. So here, in order to compose permutations, what we do, we express them in array notation and then carry out the composition from right to left. In certain books, they use it from left to right. So make sure whenever you take some book and read it out, so firstly notice that which convention they are using, whether they are using it from left to right or from right to left. In our case, we'll be using it from right to left by going from top to bottom and again from top to bottom. So let's see how this thing written in words actually work. So for that, what we are doing, we are taking two permutations here. One is sigma and one is gamma, right? And they are defined like this, right? So now we wanted to calculate what is gamma of sigma. So that means we have to compose gamma with sigma. For that, we'll be writing gamma here and we'll be writing this sigma here, right? So gamma here and sigma here. Now we have to compose them. After composition, we will have again an array where the first row is just the element of the sets 1, 2, 3, 4 and 5. Now we have to see what elements would come here and how can we have all these elements here. For that, let's see how we can proceed. For the element 1, so we'll be moving from right to left, right? So we will be moving in this direction first thing, and then so when we move from this direction to this direction, so that means we'll be first looking at the element 1. So for element 1, we'll be moving from top to bottom. So we'll be seeing what is just below 1. It is 2. So corresponding to 2, we will be moving left. So on left we have 2 here. Corresponding to this 2, which element is lying just below it? We have 4. So the answer of 1 would be 4. So you will be writing 4 here. So in words, it is gamma sigma of 1. We have to find what is 1 under the composition of gamma sigma. So you can write this to be gamma sigma of 1. You already know what is sigma of 1. Sigma of 1 is 2. So you may write sigma instead of sigma 1, the value 2. And what is gamma of 2? This is gamma. And here you have to see under 2 we have 4. So 4 is your answer and you will be writing it directly below 1, right? So let me clear all these things here. Okay. So this is how we proceed in this case. So to understand it more, let's see what is gamma sigma of 2. So we'll be talking about this element. So we have to move from right to left, right? So under 2 we have 4. So we'll be not looking at this 4, we'll be looking at this 4 here. Under this 4 we have 2. So this 2 maps to 2. So after below 2, we'll be writing 2 in the mapping gamma sigma, right? For the next one, let's see what about gamma sigma of 3. So we'll be again moving from right to left. Under 3 we have 3. So that means we'll be looking at 3 because here we have 3. So under 3 we have 1. So that means this 3 maps to 1 here under the mapping gamma sigma, right? So this 3 maps here to 1, right? So this is how we perform the calculation. Next, let us see for the element gamma sigma of 4. So we have 4 here. We'll be moving again in the direction of right to left. So under this 4 we have 5. And here under 5 we have 3. So this is the input that we are giving 4 and the output that we are receiving is this 3. So this is the answer. And next for the element 5 here, we have 5 written over here. Under this we have 1. So under 1 we have 5. So 5 would map to 5 only under the mapping gamma sigma. So 5 would map to 5 only. So this is how you obtain gamma sigma. Let's now calculate what is sigma gamma, right? So let's calculate it. For sigma gamma, what we have to do, we just have to first of all write sigma here and then gamma here, and we'll be proceeding in a similar manner. So we'll again be moving from right to left and we'll perform the calculations just like this. So here the elements are just in the correct form 1, 2, 3, 4 and 5. So let's now see what all elements would come here. For that we start with 1. You can start with any number. So if we start with 1, under 1 we have 5, and for 5 here we have 1 here. So 1 would map to 1 here, right? So 1 would map to 1. Similarly, let's take it for 3. So for the element 3 we have 3 here, right? So under 3 we have 1, and under 1 here we have 2. So this 3 would map to 2, right? So this is what we have written in the answer. So in a similar way you can complete all the entries here. So you can now see your sigma gamma is not equal to gamma sigma, because we have 4, 2, 1, 3, 5 here, and here we have 1, 5, 2, 4, 3. So the permutations, they are different to each other. So that means here the element sigma gamma is not equal to gamma sigma. So that means we can say this group of permutations, that is non-abelian. So the group of permutations is non-abelian in nature, right? So I hope you understood the introduction to this permutation group. Well, that is it for this video. Thank you for watching.